So for homework, you had to do 9.4. Okie dokie. Special right triangles. All right, 9.4. Is everybody on page 554? Oh, we got that history thing. Oh, I like that one. Did you guys like that one? I did. I took a class in college called the History of Mathematics. It was actually one of my favorite classes. All right. Okay. So number one, Peyton. Which is meant by the term special right triangle?
Right triangles that are equilateral or isosceles.
Right. And they're talking about 45, 45, 90 specifically in those degrees, and 30, 60, 90 triangles. All right, number two, it says, well, explain why any two 30, 60, 90 triangles are similar.
Because they have congruent angles.
Right. And their sides are going to be the same proportions. Okay, do you guys remember that? That whole thing of proportion, and in studying studying triangles, well, right triangles, I guess, comes into play. Okay, and that's going to be true. All right, number three. Is that true or false?
True.
True. Number four. Esther.
False.
False. Number five.
False.
False. 6.
True.
True. 7.
True.
8.
True.
True. Number 9, you had to solve for x. X equals 4 square roots of 2. Number 10.
2 square roots of 3.
So that's B is 2 square roots of 3, and what was A?
2.
2. All right. Number 11, you had to solve for H and K, and what did you get?
9 square roots of 2 over 2.
Good. Okay, so you guys rationalize that denominator, right? Sounds so fancy. Rationalizing the denominator. Sophisticated. All right, number 12. Esther, what'd you get for X?
I have A and B. For number 12.
Yeah.
5, and for Y, I got 5.
It should be, okay, now Y is the hypotenuse, right?
Yes.
And that's a 45, 45. So the relationship between one of the legs and the hypotenuse is whatever the leg is times the square root of 2. So it should be 5 square roots of 2.
Yeah, that's what I got.
Oh, okay, I just heard you say 5. Okay, all right. All right, number 13. A,
12 square roots of 3.
12 square roots of 3, and then B, 24. Okay. 15, C and D are the same, and that is
4 square roots of 2.
4 square roots of 2. All right, 17, Q, okay, Q is what?
16 square roots of 2.
And R is
16.
16. Number 19. Esther, F is
8 square roots of 8, and then 3 square roots over 3.
okay. So are you saying 8 square roots of 3 all over 3? Or are you just saying 8 over the square root of 3? Which one are you saying?
8 square roots of 3 over 3.
Okay, good. There you go. All right. That's okay. All right. Number 19. No, that was 19. Number 21. Peyton. The side length has 5 centimeters. Find the length of the altitude of the triangle. That's like saying the long leg.
So it would be
And they're giving you the side length. Yeah, so the side length of an equilateral triangle is 5 centimeters. So the whole thing's 5 going all the way around. Okay. So if you're the short leg is going to be what?
short leg is 2.5.
Right. So then the long leg is going to be square root of 3 times 2.5, and that will be
2.5 square.
yeah, and that turns out to be like roughly 4.3 something. All right, number 23. The diagonal of a square 26 inches. Find the length of the side.
18.4.
18.4. be 13 square roots of 2, and then that comes out to be 18.4 inches. All right, number 25.
13 square roots of 2.
For 25?
Yes. Would be 26 square roots of 2.
Okay, hold on. Okay, they're telling you that you got a 30, 60, 90, right? So the short leg, okay, what are they giving you there in 25? What part of the triangle are they giving you?
25? I thought we were in 23.
No, you're 25, sorry. We just did 18.4. That was Ellie. Ellie did 23, right?
Yeah.
Oh, you did 23? Oh.
Okay.
Oh. The area would be 31.2 inches.
Okay, that's better. It's feet squared.
Feet squared.
Okay. All right, good. All right.
Oh wait, I don't think I got that. I got 10.4.
Okay, for 25. Okay, so what kind of triangle are we looking at, folks?
30, 60.
Okay, 30, 60, 90. And what have they given you?
The hypotenuse.
So what do you know about the short leg?
It's half of the.
Right, so 6. Okay.
Mhm.
And what do you know about the long leg, therefore?
It's times.
6 times the square root of 3, right?
Oh.
Okay, so then to get the area, you're going to do 1/2 base times height. So you're going to choose the base. It doesn't matter which way you look at it, but it's 6 square roots of 3 times 6.
Yeah,
Okay.
For some reason I put 2.
Oh, okay. Well, that'll get you.
Yeah.
All right, 27. This says the area of a window. All right, so what did you get for that, Esther?
I got 96 square roots of 2.
No. Okay, so you have a hexagonal window that consists of 6 congruent panes. Each pane is an equilateral triangle. And they're telling you you're going 8 feet across, right? So what's the length of one of the sides of those little panes? It's going to be 4, right? Because you got 2. If you look at the widest part, right? It's you got 2 lengths there. Do you see that?
Yeah.
So the equilateral triangle then is 4. So to get the area of one of the little panes, it's going to be 1/2 the base times the height. The base is going to be 4. The height's going to be because that's going to be half of the short leg's going to be 2, right? So the long leg, that altitude is going to have to be 2 times the square root of 3. So did you get? So for one of those panes, it's 1/2 times 2 square roots of 3 times 4. That's just for one, and then you got to multiply it by the fact you got 6 of those panes. Okay, did you guys get this?
Okay,
Should I put this up?
Each pane.
I got 41.6.
Yes, 41.6
Okay. It's,
0.6 feet squared is correct. Okay, why don't you guys try to see if you can get it?
What is it?
41.6 feet squared. Got it? Got it? Did you get it, Esther?
No.
Okay.
So for each pane.
So, looking at the diagram, does it make sense that the panes are 4 feet around? Can you see that?
Yeah.
Okay. All right. So you know that. So if you've got an equilateral triangle, right? This is the situation, right? 4 all the way around.
Yeah.
Okay. So that means that if I drop this altitude, because this is where my 40, 60, 90 triangle comes in.
Okay.
That 30, 60, 90 triangle comes in. Okay. Is that so this now is the short leg, right? And that's going to be 2. There's my hypotenuse, which is 4. And then what's this long leg? Well, it's the short leg, 2 times the square root of 3, right? So if I want the area of this whole triangle now, I needed that altitude. Okay, remember it's 1/2 area equals 1/2 base times height, right? I'm not taking the area of just this triangle, I'm taking the whole equilateral triangle, and I needed this from the 30, 60, 90 so that I could get the height there, okay? So what is the base here? 1/2, well, my base here is 4. What's my altitude? 2 times 2 square roots of 3. Does that make sense? So that's just one of the panes. Okay, so this ends up being, this goes out, that goes out, this ends up being 4 square roots of 3. You know, put that in your calculator. You're doing kind of a real life thing, so you know you're not going to leave it as square root of 3. But that's one of the panes. But how many panes we got going around? We got 6. So you got to take this whole thing then and multiply it by 6 to get the area of the full window. Okay, does that make sense? Okay. All right, now the fun one. That is right here, the history one, which is on, what page was that?
Next page.
The next page. Here we go, the Pythagorean theorem proofs. All right, so we have ourselves a triangle, a square with 4 triangles going all the way around and a little red triangle in the middle. All right, and the question is, it says, can we do this proof? And it says, first of all, number 1 says, write an expression in terms of A and B for the combined area of the blue triangles, and then write an expression in terms of A and B for the area of the one small red triangle, the small red square, I mean. All right, so in terms of the blue, what they want us to do, they said write an expression in terms of A and B for the combined areas of the blue triangles. Then write an expression in terms of A and B for the area of the small red square. All right, so the blue triangles, right, they have what? They've got a base that's equal to what? And a height, the short leg is equal to what based on here? In these triangles. Yeah, so here, let me see if I can draw this. Like, if you ended up with, the whole long back is equal to what? B, right? Do you see that? And the short side is equal to A. You guys agree with that?
Mm-hmm.
So if I were talking about the area of those triangles, well, one of those triangles is going to be what? 1/2 A times B. Does everybody agree with that? That's one of those triangles. But how many of them do I have?
4.
I got 4 of these guys. So the area of the 4 blue triangles, is going to be 4 times this. So what is that? What's 4 times 1/2?
2AB.
So that's 2AB. Okay? Got that. All right, now what about the middle, the little red square? What is that? What is one of those lengths equal to?
Half of B.
It's not 1/2 of B. Because you don't really know what A or B is.
Mm-hmm.
But you know that it's the difference between A and B.
So it would be
Turns out, which one's longer? It's going to be, so the little red, so the red square, one of those lengths is really B minus A. Okay, do you guys see that? Okay, B's longer than A. Okay, so we don't want a negative, so I'm going to take the larger minus the smaller. Okay, and so the area of that is going to be what? Squared. Okay, you guys agree with that?
Yeah.
Okay, so now, the next step, number 2, says use the diagram to show that A squared plus B squared equals C squared. He says it's similar to that proof. All right, so what we're going to do is we're trying to what are we setting equal to each other? Oh. Okay, so what we're going to do is this. What's the area of the whole big square?
C times.
Yeah, so C squared, area of the big big thing, big square, is equal to C squared. Okay, you got that. So what we want to do is we want to say that the area of the big thing minus the 4 blue triangles is going to equal to the little red square. Okay? Does that make sense? All right, so we're going to say c squared, which is the area of the whole big shebang, minus 2ab has got to equal the area of the little red square. Okay, so we're setting that equal. Let's see if that's true. All right, now, what is this? What do we have to remember to do here? Is this equal to b squared minus a squared? No. Okay, it's not. What is it equal to? And this is, this really means this, b minus a times b minus a. So what do we have to remember what to do? Remember our quadratics and foiling? We got to FOIL. So b times b is
2b.
No,
B squared.
b squared. B plus b is 2b. B squared. Okay. B times minus a and minus a times b. It's going to be minus ab, collect like terms, and it's going to be minus 2ab. And then minus a times minus a. Okay, is everybody okay with how I got this middle term? Should I expand that out? Maybe not
Minus
too
a
bad.
minus. Would it be plus?
Oh, it's plus. I'm sorry. You're right. Okay, so this is minus AB times minus BA, which we're going to write alphabetically so we can see it. And then you're right. It's going to be plus A squared. Okay, and here we're going to collect like terms. So it's B squared minus 2AB plus A squared. All right, so here it is. So C squared minus 2AB equals B squared minus 2AB plus A squared. Okay, you guys notice anything about what we can do next?
combine like terms.
Okay, and what do you mean by that?
Or like subtract.
Yeah, so, well, what do they have in common, really? So what if I add 2AB to both sides? What happens? These go out, this goes out, and I get C squared equals A squared plus B squared. There you go, there's the Pythagorean theorem. It's very satisfying. All right, let's go on to trig.